Good morning. It's time for math. So today we are taking a look at lesson 15 problem set. And today is really going to focus in on using the skills that we've learned around perimeter and side lengths and the identification of the missing side lengths and put all that understanding into word problems. So, number one says Mrs. Coslow put a border around a 5 foot by 6 foot rectangular bulletin board. How many feet of border did Mrs. Coslow use? So, this is going to, like some of the ones we found yesterday, it's going to feel very area based, right? So, we have a 5 foot by 6 foot rectangular bulletin board. And so make sure you do your labeling. And how many feet of border did Mrs. Coslow use? So remember, border is another word for like outside edge. So this right here, when you see words like that, that's your clue in the sentence that you need to calculate the perimeter. So instead of doing 5 times 6, which would give me the area of the inside of the bulletin, I need to determine the missing side lengths and add them up. So knowing that this is a rectangle, this side length is going to be equal to this side length. So I can label that there. And on this side, if I need this one, right, these two are related to one another because in this quadrilateral, both sides are going to be of equal length. So I'm going to go ahead and put that there. Now I'm going to go ahead and add it all up next. So I have a 5 foot plus a 6 foot. Remember, just check them off. Plus a 5 foot plus a 6 foot, right? So I am kind of systematically going around. And then what I'd like to do is add them up. Now you can use parenthesis work to kind of organize it or not, but 5 plus 6 is 11. Plus 5 plus 6 is 11, which would give us a total perimeter of 22 feet. Now, when we have these nice quadrilaterals, again, if you want to start playing around with the formula and organizing it that way, your problem would look more, I'm trying to see why this is so light. Problem would look more like I have 2 5s plus 2 6s, right? So this is an alternative way, and the one that you will eventually progress to. 2 times 5 is 10, plus 2 times 6 is 12, which is 22 feet. Okay, so I want you to do whatever you feel like is going to keep you most accurate. And I also want you comfortable right now, right? We don't need to extend into this formula just yet, but if you're really understanding it, and again, that's what you're seeing, then embrace it. Okay, number 2 says Jason built a model of the Pentagon for a social studies project. So right away, my brain is thinking penta, 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 penta. That's 5, right? 5 sides. For a social studies project, he made each outside wall 33 centimeters long. What is the perimeter of Jason's model Pentagon? So we have a 5-sided figure. And one of the things you're going to see in the lesson today is we are going to be using some larger numbers. So that'll give us a little fun challenge. All right, so Pentagon. Pentagons, the easiest way to draw them is to kind of make that house shape, right? And each side length, it says, is 33 centimeters long. So that means every side length here is going to be 33. I'm going to squeak in my unit of measurement over there. And it says that I need to find the perimeter. Now, if we're looking at this, right, we're essentially looking at a repeated addition problem of a whole lot of 3s. Look at all those 3s. So there's 4 sets of 33. So looking at this, right, I'm going to show you two strategies. The first is that we can add this up, right, and do our pull down method. So let's start there. So I have 33 and 33, which is nice and comfortable to add up, right? 66 mentally. I have another 33 and 33, which I can add up, 66. And then I have this one out here that I've not done anything with, so I need to pull that down and add in the 33. Now I'm going to continue on. 66 and 66, I know it's going to require some regrouping, so I'm going to go ahead and add that up. I have 6 and 6 is 12, regroup my 10. I have 6 and 6 is 12 plus one more makes 13. Okay, so I've got 132. Now do not forget about this additional 33. It has not gone anywhere, and we have to make sure it's included in our perimeter. So now I'm going to go ahead and take this 132 and I'm going to add on my 33. Now save a little bit of room because I do want to show you another strategy because some of you are really going to like it and probably want to use it. Oops, so 165 165 centimeters is the perimeter of this pentagon. Okay, so if you kind of rewind, we haven't done distributive property in a while, but you can use distributive property for this problem because we have a repeated addition problem of 533s, right? So we basically have 5 times 33. Now, that's not a problem most third graders quickly calculate, right? Or have learned the algorithm for anything like that. But you guys are super smarty pants and you have learned distributive property. So you can break this 33 apart. So I want to remind you how to do that because you guys know distributive property is like my favorite property. So if I were to break up that 33, my 5, right? My 5 is a number I can work with. It's the 33 that's giving me the challenge. So if I'm looking at this, what is that 3 worth? It's worth 3 tens, right? So I also love parentheses, right? So I can do 5 times 3 tens, which is, right, 30, plus I can do my 5 times 3 ones, and break it down that way. So even though this is leaving me with a 5 times 30, you guys know when it's a multiple of 10, right, we can think 5 times 3, that's 15, shifted 110 over, right, on a place value chart, would push this 15 over, and we would add this 0 because it's being pushed over a column on the place value chart. Then we have 5 times 3, which is 15. I add those two answers up, and voila, I have the exact same answer as I got by adding them all. Okay, so we're going to kind of work through, I'm going to keep modeling both because I think this strategy here, this is awesome, right? This is going to get you what you need, especially because we're all super accurate at, at addition. So this here, though, also gives you a chance to practice a strategy where if you were ever presented with a problem that maybe you haven't been exposed to and taught at an instructional third grade level, it reinforces how to use a strategy to solve those bigger problems independently. And that's one of the things I love about distributive property. Okay, the Holmes family plants a rectangular 8-yard by 9-yard vegetable garden. Okay, so I've got my dimensions right here. How many yards of fencing do they need to put? A fence around the garden? Okay, so fence around, right? You picture a fence. Fences go around. Whoop, you can't see my finger anymore. So fences go around things. Okay, so it's an outside edge. So that's telling me perimeter, not area. And I have an 8 by 9. Okay, so there's my 8 by 9. I've got 8 yards by 9 yards. And we're going to use a similar process that we did in number 1. So we're going to use the addition strategy and checking off everything. And then we're also going to try the formula arrangement of the problem. Since we've got this nice, neat rectangle, we might as well. So I have an 8 yards here, and I have a missing side length here. This is a rectangle, so therefore this side length is going to be congruent with this side length. So I'm going to put that there. Here I have 9 and I have a missing side length. Again, we know rectangles have congruent side lengths. So I have 9 yards here. Now the first, right, is just to systematically go off and check each one and set up your addition problem. I'm going to go ahead and cluster these with parentheses just because it does, I think, help organize the work. So 8 plus 9 is 17. And this one is basically just doubled, right? 17 and 17. I know that's going to require some regrouping, so I'm going to go ahead and write that out carefully. So I have 34 yards. Whoop, didn't do very good organization there on my paper. Okay, now let's take a look again and just practice the formula for perimeter. So formula for perimeter, right, is 2 times the length plus 2 times the width. So 2 times the length, I would say 2 times, I have 8 because I have 2 8s, plus 2 times my width, which is 9, sets me up just in a slightly different way, right? It uses a little bit more organization and multiplication, but it's going to arrive me at the same answer. 2 times 6 is 16, plus 2 times 9 is 18. And if I add those up, 14, I still get 34 yards. Okay, so this is an either or. Again, I want to show you because I know so many of you will kind of gravitate towards this style of solving it. And I know a ton of you are going to like this one better. So it's always good to have options, right? Because mathematical thinkers solve things in a variety of ways. So I want you to kind of figure out for yourself, what do you connect with when you reason through these problems? All right. Problem set 15. Marion paints a 5-pointed star on her bedroom wall, and each side is 18 inches long. What is the perimeter of the star? Yee, okay. So we're working with a bigger number than we normally do, right? That's a whole lot of 18s. Now, I want you to pause for a second because this particular problem is exactly what I was talking about in terms of not wanting to miss a side length. This has a bunch of side lengths, so you really need to be very careful as you work your way around to make sure you get the right number of 18s, because we're talking about side lengths. We're not talking about vertices or points here, right? So I have 18, I have 18, I have 18, I have another 18. Look at all these 18s, right? That's a ton of 18s. So you got to squish them all in there. And you can see me kind of putting little tick marks on my side lengths because it does really help me just kind of keep track. They are not parallel line symbols on this situation here. Okay, so there are all my tick marks. So now I got to count them up. And I'm going to list them. And I'm going to check them off as I go. And then we can talk about an alternate strategy to finding the calculations. So I have 18. That's 1, 2, 3, 4, 5, 6, 7, 8, yikes, 9, 10. Do you imagine writing that out? Now, let's look at this. That is a whole lot of 18s. In fact, it is 10 18s, right? Okay, so we're going to go ahead and tackle it both ways, but which way do you think it's going to be the most efficient? Yeah, that one, right? Because we know if we're multiplying a number by a multiple of 10, we can multiply and shift over on the place value, the number of tens it has. We're going to start off with addition though. All right, so here I have 18 plus 18. I'm going to just squeak in a vertical problem here so we can make sure that we're launching this addition chain correctly. So 18 plus 18 gives me 36. So I've got one there, one there, one there, one there, and one here. Ooh. Now this addition, it's going to be a lot of work, right? Let's keep going though, because we can do it. So I got 36 plus 36. I mean, the one thing that is nice about this is kind of once you've done one calculation, it applies to like the rest down the line. So that gives me 72. So this is 72. This is 72. And again, you know, if you're taking CASP or you're doing a math assessment or you're working in a workbook that is kind of pushing your thinking, you go to the strategies that make sense to you and that you can apply. This works and you have the persistence, go for it. All right, so now I got 72 and 72. Okay, 72 and 72 gives me 144. I mean, it does look kind of pretty, right? All this little connections of math and breaking it all down all the way. So now I'm going to take my 144 and add on my 36, and I end up with 180. Look at that answer, 180. You know, that is an answer that I know is going to match this one, right? Because I'm basically taking 18 and shifting it over one place value because I'm multiplying it by 110. So 1 times 18 is 18. And if I had that on a place value mat, I would just push those over and fill that one's place with a 0 and create my 180. All right, did they tell us the unit of measurement? Inches. Okay, there we go. Number 5, the soccer team jogs around the outside of the soccer field twice. Okay, outside of the soccer field, right? That is telling me again an edge. The rectangular field measures 60 yards. Big numbers today. All right, 60 yards by 100 yards. And they're going around this twice. Right, so I've got 100 yards up here, 60 yards here. This one, we could just, we can just check them off and add them. 60 plus 100. We know we need the perimeter at least one time, right? Because they go around twice. So first we have to figure out how far they're running just on the first lap. So I have 160 and 160. And if I add those up, I'm going to go ahead and stack it over here where I have more room. Okay, so I have 320 yards, which is one lap, but they do 2 laps. So I can take this 320 and add it to itself to double it. 0, 4, 640 yards. Okay, so that is how long they ran. They ran, I haven't been doing my sentences, but mainly because our paper has been so full with calculations and models. They ran 640 yards. But on your homework, please write a statement. All right. Number 6, Troop 516 makes 3 triangular flags to carry out a parade. They sew ribbon around the outside edges, keyword, right, of the flags. The flag's side lengths measure 24 inches. How many inches of ribbon does the troop use? All right, so 3 triangular flags, right? So it's like they're making a pennant flag. And we have 24 on every side of every flag. Okay. Now on this one, rather than make a huge list of 24s, we're going to think a little bit more strategically. Because if I can figure out one of the flags, then I can use that amount to either multiply or add on those additional amounts. So I'm going to focus just on one flag, and I'm going to say 24 plus 24 plus 24, and we'll go over the multiplication of this in a second. We have 24 and 24 is 48, and 48 and 24, I feel regrouping. I'm going to go ahead and stack 72. Okay. So one flag is requiring 72 inches of ribbon to go around the perimeter. If I wanted to look at this as the repeated addition that it is, as multiplication, I have 324s. Okay. Now, 324s, you can use distributive property like I showed you before. So if you wanted to, okay, again, optional, do what works best for you. 3 times how many tens is this? It's 2 tens, which is worth 20. So I could do 3 times 20 plus, my 4 is in my ones place, 3 times 4, and add up those amounts. So 3 times 20, right? I'm thinking 3 times 2 is 6. Shifted over a 10 gives me 60, plus 3 times 4 is 12. That gets me a total of 72 also, okay? So that would be an additional strategy to use. Now that I have 72, it's like this is 72 inches. Oh, I should not put that in the middle because that makes it look like it's the area. Okay, so this has a perimeter of 72 inches. This has a perimeter of 72 inches. And so does this one. Do we see a new math problem emerging here? 72, 72, 72. So I can add these up, or I could use distributive property. Okay, so this one's a little bit of work, but great practice, and you can do it for sure. 72 plus 72 is 144 plus another 72. Let's do 144 plus a 72 equals, that's 11, 216. Okay, so I'm going to say perimeter equals 206. I'm going to put my variable up there. 216 inches. It's not required, but I didn't have enough room to squish it in there anyway, so we might as well fancy it up and throw the variable in there. Okay, so I've got 216 inches. Now, just in case you're liking that distributive property, we have 3 times 72. Wow, look at that impressive problem, right? We don't get to see that all that often in 3rd grade. So 3 times 72, if I want to break that baby down, I can say 3 times whatever this value of this digit is, which is 70. Exactly. So I could do 3 times 70 plus 3 times my value of this digit, which is just 2 because it's in the ones, okay? 3 times 7 is 21, and I am multiplying it by 110, so it shifts over one place value, and I get 210. And then I get 3 times 2, which is 6. And this perimeter also equals 216 inches. Now, you do not have to show me both methods, right? Our problem sets are being used during distance learning to instruct. So now that you've seen both strategies and you've taken kind of notes as you've gone, when you go to enter your homework tonight or today or this morning or whenever you choose to do it, I want you to kind of think about which one is going to work best for you. All right, I can't wait to see which one you pick. Don't forget to submit your homework. I'll see you guys tomorrow.